UDC.
Good afternoon. I'm Ron Yoshimura. I'm a principal consultant for UDC. And yes, I'm going to talk about our favorite subject, GIS data. Utilities are constantly striving to provide quality GIS data to critical downstream applications like in ADMS. These applications are highly sensitive to source data and may not function, or even worse, may give misleading results. So how do we ensure we are providing the most accurate data possible to these critical downstream applications? One method that we use is a GIS ADMS roadmap. The roadmap provides a clear path from current state data and applications to future state ADMS applications and quality source data. We also like to incorporate change management in the roadmap, which identifies new business processes and training requirements for the new applications. One of our customers, Core, followed an ADMS roadmap and is now developing an ADMS RFP and will select a vendor for ADMS implementation in 2026. The first step in our GIS ADMS roadmap includes performing a GIS data assessment. When we assess the current state of the GIS, we are looking for connectivity. Is the GIS connected properly from the substation to the service points or distribution transformer? Are required attributes for supporting an ADMS populated and consistent, like phasing, voltage, circuit or feeder ID, and switch positions? Are business rules in place for the GIS? Is the MV network connected to the LV network via distribution transformers? And domain values, are domains used and consistent? Next, for the future state, we identify applications the data is to support. Is it in OMS or advanced DMS applications? This slide is from our partners at Aspen Tech, and it's showing the data engineering workbook. The workbook maps source data to the Aspen Tech schema that supports Aspen Tech ADMS products. So what are the future ADMS applications? Is it DPF, FLISR, VVC, VVO, or others? Each of these applications have unique data requirements. From the slide, we have the Aspen Tech schema on the left in the white column. We have the source data in the center, and what applications the data is to support in the blue box on the right. In this case, it's distribution power flow. For an OMS, the GIS may provide enough information to build the network model. But for an ADMS, additional data will be required from other enterprise applications. For example, for VVO, additional information may be required from field devices like LTCs, cap banks, breakers, DERs, and AMI meters. We also like to incorporate change management, where we review current state applications and future state ADMS applications. This helps identify new or different business process flows, identifies new applications, which helps determine training requirements. With this information, the roadmap can define how to get to the future state. We also suggest incorporating the latest in GIS technology, specifically for Esri customers, the utility network. The utility network provides real-world modeling constructs and supports high-fidelity GIS data. By migrating to the utility network, GRU and Core avoided future rework had the ADMS been implemented on the geometric network. One of the other methods we use to check the quality of the source data is to complete a UN assessment. The assessment identifies how to get from the geometric network to the utility network. The assessment maps the current GN model to the UN schema. We also build some subnetworks, which gives us a good idea of what the data will look like in the utility network. This also identifies connected features and, maybe more importantly, disconnected features. The UN assessment also identifies errors in the source data, errors that are important to correct for the utility network and also for supporting an ADMS. Using the results of our UN data assessment, we develop short and long-term mitigation plans for correcting the errors. From the slide, we can see UN errors and potentially ADMS source data errors like missing midspan devices, missing junctions, stack point features, and duplicate vertices. Core is in the process of migrating to the utility network and is developing an ADMS RFP. GRU has already migrated to the Esri utility network, upgraded key software, and added supplemental data. GRU added substation data to support advanced DMS applications in the future. GRU also upgraded their AspenTech GIS extractor from Maven to Leitmotif. When all the source data comes together and an ADMS network model can be properly built, important ADMS applications like Flizzr can be reliably executed. This slide is showing an outage area with the customers who have called in and the fault location identified by Flizzr. So to recap, a couple of options for checking source data: create a GIS ADMS roadmap, assess the current state source data and applications, identify future state applications and their data requirements, and then also consider migrating to the utility network and or performing a UN data readiness assessment, which identifies other data deficiencies in the source data.
UDC